The last section in this unit is on solving rational equations. So just like solving any kind of equation, the goal is to find out what x equals that would make the two sides of the equation equal to each other, make the equation true. The difference with rational equations that we have to be careful with that's not always true of other equations is sometimes we can get solutions that are not really solutions. We get an x value out at the end that either doesn't work, even though we think it should, or it's a whole or it's an asymptote, so we've always got to check for extraneous solutions at the end when we finish. So the best way to do that is to plug your solutions back in again and see if it actually makes both sides of your equation true. And also to watch out for excluded values. Excluded values are those values that would make the denominator equal to 0, which we know would either be a vertical asymptote or a hole in your graph. So let's get started with our first example. Solve. Check for extraneous solutions. So we have 1/3 plus x over 4 equals 2. Now the best way to do these, I think, is to get rid of your fractions so you don't have to think about fractions while you're solving. To do that, we're going to multiply all our terms by the lowest common multiple of the denominators of our fractions. So the denominators of our fractions are 3 and 4, and we want to find a number that can be divided by 3 and a number that can be divided by 4 that I could multiply everything by in order to get rid of my fractions. And so that number in this case is 12. So I'm going to take every single term and multiply by 12. So 12 times 1/3, 12 over 3 is 4. 12 times x over 4 is going to give me 3x. And 12 times 2 is going to give me 24. Then I'm left with just solving this equation like a regular everyday equation. So subtract 4 to the other side to get me 3x equals 20. And divide both sides by 3 to get me x equals 20 over 3. Now to double check that this actually works, this is our part that we check for extraneous solutions, we need to plug it back into my original equation. So I have 1/3 plus 20 over 3 over 4 equals 2. 1/3, I can simplify this by going, well, 20 over 3 over 4 is actually the same as 20 over, divide 20 by 4 actually, which gives me 5 over 3. 20 divided by 4, I can divide the numerator by this number on the bottom, or I can multiply by 1/4 if that makes you happier. So 20 over 3 times 1/4 is the same as dividing by 4, and then simplify, this would be a 5 and this would be a 1, so this gives me 5/3, and that is equal to 2. 1/3 plus 5/3 is 6/3 equals 2. Check, that's true, so my solution is not extraneous. This is the actual solution that I'm looking for. So to check for extraneous solutions, I'm always going to plug it back into my original equation to make sure that it actually works. Taking a look at this example over here, second example, again, I want to multiply all my terms by my lowest common multiple of my denominator, so 3x and 5. The lowest common multiple is going to be 15x. 15x times 1/3 is going to give me 5x. 15x times 4 over x is going to give me 15 times 4 is 60, and the x is canceled. And 15x times 2 over 5 is going to give me 6x. Then I just solve this like a normal equation. So subtract 5x from both sides, I get 60 equals x. Check for extraneous solutions. So I'm going to do 1/3 plus 4 over 60 equals 2/5 to figure out if this is actually true. 4 over 60 can reduce to 1 over 15. And in order to add these, I need to give them a common denominator of 15. So this 1/3 is going to be 5 over 15 plus 1 over 15 equals 2/5. 6 over 15 equals 2/5. And that is true. If I divide my top and bottom here by 3, then I get 2/5. So check, this works. So this is my actual solution. And my excluded value What I couldn't have plugged in if I gotten it as an answer would have been 0, because that would make this denominator equal to 0. So my excluded value, x, is not allowed to equal 0. Often this is handy to note actually at the beginning rather than at the end. Alright, why don't we try a couple more? Next one. 2 over 3x plus 1/6 equals 4 over 3x. Multiply by your lowest common multiple. Actually, try this one on your own. See if you can figure this one out for yourself. Then come back and check your solution. Don't forget to write down your excluded values. So we get an answer of x equals 4. Plug that back in to see if that actually does give us a solution, and it does work. And our excluded value was again x equals 0, because if I plug 0 in here, that would make this divide by 0 and this divide by 0. This next one, similar idea, except my denominators get a little more complicated when I'm looking for the lowest common multiple of my denominator. So in this case, I want to multiply everything by 2 times x plus 3. That would be the lowest common multiple of my denominator, because I have a 2 here, an x plus 3 here, and this is like over 1, so that doesn't really count. So 2 times x plus 3 to each term. I get x times x plus 3 for my first term, minus 2 for my second term, times, nothing cancels, so this is 2x, x plus 3 on the other side. I'm going to do my distribution, so x times x is x squared, x times 3 is 3x, minus 2 equals 2x squared plus 6x. Move everything over to one side. I'm going to move it to the right-hand side just because that keeps my x squared positive. So that's going to give me 0 equals x squared plus 3x plus 2. In order to solve this, you have to factor it. So this is x plus 2 and x plus 1. Remember, multiply to 2, add to 3, which gives me solutions of x equals negative 2 and negative 1. Excluded values from the beginning would be what would make x plus 3 equal to 0, which is x is not allowed to equal negative 3, which neither of these are. I'm going to leave it up to you to type these into your calculator and double check that both of these solutions actually do work. Make sure the two sides are equal. If either of the solutions fails, cross it out. It's an extraneous solution. Alright, similar idea here, but in order to find our lowest common multiple, we're going to have to factor our denominator. So we're going to factor this x squared minus x minus 12 into an x minus 4 and an x plus 3. And what do you know, that just happens to be my other two denominators. So that is my lowest common denominator, my lowest common multiple of the denominator. So I'm going to multiply every single term by x minus 4, x plus 3. So when I do that to the first term, it's going to cancel with the denominator and leave me with only a 2x. When I do it to the second term, the x plus 3's will cancel and leave me with a 5x minus 4. And when I do it to the other side, the x minus 4's cancel, and I'm left with a 2x plus 3. All right, do your distributions. And then in this case, we have no x squareds, so we'll be served best by bringing all your x's to one side and all your non-x's to the other side. So moving this 2x over leaves me on this side with just a 5x, and on the other side a 26. Which gives me, as a solution, x equals 26 over 5. From the beginning, my excluded values would have been what would make this equal to 0 and this equal to 0, so x is not allowed to equal negative 3 or 4, which this falls outside that range. So again, type it into your calculator, double check your answer, make sure it actually works. Which it does. Happy day. So this would actually be our solution. By the way, a quick way to be able to plug this into your calculator is to store this as one of your variables and then type in this expression using your variable and see if the two sides come out equal. Alright, why don't you try this next one on your own? Again, factor the denominator in order to find the lowest common multiple of the denominators, and then multiply everything by that lowest common multiple. Alright, so our least common multiple was x plus 3, x minus 3. So you multiply that to every single term. distribute, collect your like terms. If you want to simplify it by dividing everything by 2, that's a bit easier to factor. And then you should get x plus 3 to x minus 3 as your factors, which should give you the solutions of negative 3 and 3 over 2. But because of our denominator at the beginning, x should not equal plus or minus 3. So minus 3 is an extraneous solution. Get rid of it. We don't want it. If you tried to plug it into your calculator as a solution, it would give you an error. And 3 over 2 should check out just fine as a solution. Alrighty, something similar but just a little bit different. In this case, you don't have an addition or subtraction of rationals. You just have a rational on one side and a whole number on the other side. These are actually easier to solve than the other kind if we want to use cross multiplying. So remember, if this isn't a fraction, if this is a whole number on one side, you can always make it a fraction over 1. And then to solve this, multiply the top of one side times the bottom of the other side, and then the bottom of the first side times the top of the other side. So this would be 12 2x minus 1 equals 1 times 5x plus 6. That will get rid of your fractions, and now it turns into a regular equation. So do your distribution. So you got 24x minus 12 equals 5x plus 6. Get all your x's to one side and all your not x's to the other side, and get x by itself by dividing by 19. Now my extraneous solution, x is not allowed to make this 2x minus 1 equal to 0, so x is not allowed to equal 1/2. And just double check on your calculator that 18 over 19 actually does give you a viable solution. And it turns out, even though it's a funky looking number, it does give you a nice solution. This second example is already set up for you with fraction on each side, so you can cross multiply top of one side times the bottom of the other, bottom of one side times the top of the other. So I get 12 times 2x plus 1 equals 6 times 4x minus 1. This cross multiply only works if there's an equal sign in the middle. Don't get it mixed up with fraction multiplication. When you multiply fractions on the same side of an equal sign, it's always top times top and bottom times bottom. But when we cross multiply, top of one side times the bottom of the other, etc. Do your distribution. Try to get all the x's together. Uh-oh, what happens? We get subtract 24 from each side, 24x. And we get 12 equals negative 6. This actually tells us, because this is never true, 12 is never equal to negative 6, that there is no solution. So if you ever end up with an equation that has no solution, two sides that are not equal to each other and yet you have no x's left, you've got no solution. And if we needed them, our excluded values, this would be x equals 1/4. So x is not allowed to equal 1/4. And on this side, x is not allowed to equal negative 1/2. Those are excluded values. But since we have no solution, no x values are actually ever going to work. All right, underneath here, we've got to try it for you. Pause your video, try these last 3 questions, then come back and see how it goes. All right, double check your answers. Pause your video if you need a little more time to check your answers. The last one is one of those weird ones where you think you found a solution, you plug it in to check it out, and it turns out it doesn't actually work. So that is a no solution. So again, pause your video if you need more time to double check your answers, and then write down your summary, and you're ready to head for the homework. Good luck!